We are continuing here with part 6 of section R.8, nth roots and radical exponents. So let's note that if a is a real number and m and n are integers containing no common factors within a number that's greater than or equal to 2, then a to the 1 over n can also be written as the nth root of a. And a to the m over n can also be written as the nth root of a to the mth power, or another way to write that is the nth root of a quantity to the mth power. So in other words, you can raise a to this power and then take the root, or you can take the root and raise to the power, because the order of those doesn't change the result. Provided that the nth root of a exists, because we know that you can't take the square root of a negative or the fourth root or any even root of a negative. So it has to exist for this to be true. So notice this is really the same thing, because here we're just saying that the numerator is that power here. Well, here the numerator is 1, so the power on a is 1. Okay, so we are supposed to write each of the following expressions as a radical and then simplify it if possible. So, to the 1/2 power, the denominator is our index, so it's square root. Remember, with square root, we don't write the 2 right here. To the 16th to the 1st power, which is just the square root of 16 or 4. Now we have x to the 2/3, that's just the square, no, what would that be? Not square root, the denominator's the index, the cube root of x squared, or we could write that as the cube root of x and then square it. Either one of those would be correct. Here we have 3abc to the 1/5 power, so that just means the bottom is the index, the 5th root of 3 times a times b times c. Okay, and at 5b it says to rewrite each of the radicals with a rational exponent. You know, rational exponents just mean fractions. A rational number is a fraction. Okay, so we have 6x, the cube root of 6x. Remember, the index is the denominator, the power here is the numerator. So this is just 6x to the 1/3 power. This would be 12c to the, that's the denominator, 5, that's the numerator, 3/5 power. And this one would be 2x over y to the 5/6 power. And finally, we have negative 64, so to the 2/3, so that means it's a cube root of negative 64 squared, which I really don't want to square negative 64. We can simplify this one. It doesn't have variables in it. So let's keep going. I'm instead going to write it as the cube root of negative 64 quantity squared. I'll square after I find out the cube root. And the cube root of a negative, that exists because it would be negative 4, because negative 4 times negative 4 times negative 4 is negative 64 squared, and now that's easy, 16.